So we had to introduce functions, and we said the function's kind of like a machine where you plug in an input x, right? You plug in an x, and out the other side comes a y. And for each x, there's only one y. Or some people might visualize it this way, right? You got like a machine here, f, the input, x, goes in the machine, and out the other side comes the output, y. So something that we often write is what's called functional notation for representing how the input goes in and how the output goes out. Functional notation. We write f, parentheses, x, which we say f of x, that's the way we say that. F at x sometimes, or f of x, either one, equals y. Yeah, so the idea is you got this function here, f. So the input is x, and the output on the other side is y. So f of x equals y. So x goes into the red machine, and it comes out the other side as a y. The output becomes y. Now, a lot of times this y, there'll be some other, there'll be an equation in place of y. So who knows, maybe like the y here will be x squared. So what this gives an equation. The functional notation being f of x equals, so instead of a y there, you can put x squared. So if I wanted to evaluate this, evaluate f, let's say I wanted to find f of -1, what I do, I take for an x value, as an input I take -1. So I'm going to plug that in. I'm going to make a template here. I'm going to make a template in place of, so I'm doing a blank squared, right? This is representing my template here, my blank squared. In place of my x, right, I'm going to put a -1. So I'm going to do a -1 squared. And we know -1 squared is simply 1 because squares kill off negatives. So let's do another 2. If I wanted to find f of 3, for example, I'm just going to take 3 and plug it in. So here's my template. I'm going to do blank squared, and in place of the x, once again, the x, we're going to get a 3. So we're going to get 3 squared equals, well, 9, right? And you can just keep plugging in numbers if you wanted to. So that's the idea. So, some exercises here. Consider the functions. So we're going to write our functions in functional notation. This is the way you'll normally see them. F of x equals 3x minus 4x squared. So my input is x. My input is x, and my output is going to be 3x minus 4x squared. And I got another function, g of x equals 2 minus x on top, and on bottom, so we got a fraction, on bottom 3 plus x. So here the input is x, and the output is 2 minus x divided by 3 plus x. That's the way the function works, inputs and outputs. Evaluate the following. All right, number 1. We want you to find f of 1. F of 1. So I'm going to call the f the blue function, and the g I'm going to call the red function. So we're plugging in a green. Let's say the x values are 1 here. Yeah. X values are 1 here. So we had, what, 3x minus 4x squared. So I'm going to plug a 1 in for x. I'm dealing with a blue situation, right? Blue situation. So I'm going to do what? 3 times blank minus 4 times blank squared. In place of the x, I'm going to put a green 1. Now you got to do order of operations here. So you're going to do 3 times 1 is 3. Simplify that. When you're doing the 4 times 1 squared, make sure you do the exponent first. Exponents come before multiplication, so I'm going to do 4 times, and you want to do the 1 squared first. So 1 squared is 1. Then simplify that. 3 minus 4 times 1 is 4, and then 3 minus 4 is negative 1. So you evaluate it. Your input is 1, your output is negative 1. So the x value is 1, the y value is negative 1. So order of operations is important, all right? You got to do the exponent first before you do the multiplication by 4. All right, here's the second one. Now we have what? F negative 3. F at negative 3. What is that equal to? All right, so your function is blue, and your input is a green, negative 3. All right, so we're going to write down our template for f, right? It's 3 times blank minus 4 times blank squared. In place of the blank, I'm going to put a negative 3, right? That's where my x value would go. So we're going to do 3 times negative 3 is negative 9 minus 4. So we're going to take negative 3 squared first, right? Negative 3 squared first. Do exponents before multiplication. Negative 3 squared was 9. Let's see, we got negative 9 minus, what's 4 times 9? 36, right? 4 times 9, 36. And negative 9 minus 36 is negative. What's that? 45, right? Minus 45. All right, how about a number 3? Let's just say f of a. So our input, x, is a. Now, a is just an abstract variable, right? It's a letter. It's really not a number in particular. So all we're going to do, we're going to write down our template. 3 blank minus 4 times blank squared. That's the template for f of x. Instead of putting an x there, we're going to replace our x with an a. Then simplify that. How do you simplify that? Well, you just say this is equal to 3a minus 4a squared. That's it. 3a minus 4a squared, that's simple. All right, a number 3. No, number 4. So we have f of negative a this time. So same situation. You have an abstract negative a you're going to plug in. So we're going to set up the template for the f function, right? It's 3 times blank minus 4 times blank squared. In place of the x, where the blank is, we're going to put minus a. Now you have to be careful when you simplify this one. The question is, what is 3 times negative a? Well, we know a positive times a negative is a negative, so it's going to be minus 3a. And we have minus 4, and then we have to perform minus a squared. So when you do this, minus a squared right here, be aware that the square kills off the negative. Square kills off the negative. So you end up with simply a squared. Well, that's not doing it right. A squared. Yeah. And again, that's because the square kills off the negative inside of the parentheses. So even powers kill off negatives in parentheses. So that's our answer. That's our answer right there. Well, what happened there? I don't know. Something happened. Okay, that had a parentheses. Okay, that's our answer right there. All right, let's do a 5. G of 0. Oh, what was the G function? What was the G function? It was red, right? So the input is x and green. So it's 2 minus x over 3 plus x. 2 minus x over 3 plus x. So we're dealing with the red. So we're going to do 2 minus blank over 3 plus blank. So in place of the x, we're going to put a green 0 right here. So 0 and 0. Now you simplify that. What 2 minus 0 on top is 2. 3 plus 0 on bottom is 3. So your answer is 2/3. All right, getting somewhere. This is number 6. We're doing g of negative 2. Evaluate that. So g is our function. And the input, the x value is negative 2. So we're going to make a template for the g function. It's going to be what? 2 minus blank over 3 plus blank. And in place of the blanks, we're going to put a minus 2. And then simplify that. So on top, look what happens. You get a double negative, right? You get 2 minus negative 2. The double negative becomes a plus. So you get 2 plus 2 is 4. And on bottom, you got 3 minus 2. 3 plus negative 2 is the same thing as 3 minus 2, right? You get 1. So 4 over 1 is 4. So your input is negative 2. Your output is 4. And we'll do one final problem. G of, let's say, negative 3. Let's evaluate that. So we're dealing with the g function, the red function. So we're going to have 2 minus. Not erasing, there it goes. 2 minus a blank over 3 plus a blank, right? So normally you have an x in the blank, but this time our x is negative 3. So we're going to put negative 3 in those places where the x would be. So on the top, it looks like we have a double negative, right? So you get a plus. So it's going to be a 2 plus 3 on top is going to give us a 5. And on bottom, we have 3 plus negative 3. 3 plus negative 3 is same thing as 3 minus 0. That's 0. Now, remember, in math, you can't divide by 0. So what do you do here? 5 over 0. If you can't divide by 0, this is undefined. Is undefined. So g of negative 3 is undefined, is your answer. Or you could say, one other way to say this. So if you imagine this being a machine, g is a machine. Okay, draw a picture. G is a machine. So over here we have the stuff, this is called the domain, right? This is the stuff that we can plug into the machine. You can plug in some x values. And you can get out over here, as they call this the range, right? This is the stuff that comes out. The y values. So sometimes there are values that you're not allowed to plug in, like negative 3 is something you're not allowed to plug in the machine. It's outside of the domain. But what happens if you try to plug in negative 3 into the machine? It breaks. The machine goes kaboom. So negative 3 is not in the domain. It's not an acceptable value. So you could also say here, let me just go up. You could also say, let me write it in green, negative 3 is not in the domain of G. So there are two ways to say this. First of all, G of negative 3 is undefined. That's the most popular way, but also could say negative 3 is not in the domain of G, right? It's not a valid input. All right, so we'll pick up probably in our next video with looking at domains of functions.